Welcome to T-Teach, Quadratic Inequalities. Today we're finding solution regions, not just points. Understanding greater than and less than, finding critical values, testing regions, and writing solutions. Let's begin. First, what's the difference? An equation like x squared minus 5x plus 6 equals 0 gives us exact values. X equals 2 or x equals 3. But an inequality like x squared minus 5x plus 6 greater than 0 gives us ranges, x less than 2 or x greater than 3. On a number line, we mark our critical points at 2 and 3, then shade the regions where the inequality is true. See the difference? Ranges instead of points. Example, x squared minus 5x plus 6 greater than 0. Step 1. Solve when it equals 0. X squared minus 5x plus 6 equals 0. Factor x minus 2 times x minus 3 equals 0. So x equals 2 and x equals 3. Step 2. Test regions. Region 1, x less than 2. Pick x equals 0. 0 squared minus 5 times 0 plus 6 equals 6. Is 6 greater than 0? Yes. Check mark. Region 2, between 2 and 3. Pick x equals 2.5. 2.5 squared minus 5 times 2.5 plus 6 equals negative 0.75. Is negative 0.75 greater than 0? No. Cross. Region 3, x greater than 3. Pick x equals 4. 4 squared minus 5 times 4 plus 6 equals 2. Is 2 greater than 0? Yes. Check mark. Answer, x less than 2 or x greater than 3. Example 2, x squared minus 4 less than 0. Step 1, solve x squared minus 4 equals 0. Factor using difference of squares, x minus 2 times x plus 2 equals 0. Critical values, x equals negative 2 and x equals 2. Step 2, test regions. Region 1, x less than negative 2. Pick x equals negative 3. Negative 3 squared minus 4 equals 5. Is 5 less than 0? No. Cross. Region 2. Between negative 2 and 2. Pick x equals 0. 0 squared minus 4 equals negative 4. Is negative 4 less than 0? Yes. Check mark. This region is shaded green. Region 3, x greater than 2. Pick x equals 3. 3 squared minus 4 equals 5. Is 5 less than 0? No. Answer, negative 2 less than x less than 2. Here's the complete 5-step method. Step 1. Replace the inequality with equals. X squared minus 5, x plus 6, greater than 0 becomes x squared minus 5, x plus 6 equals 0. Step 2. Solve for critical values. Factor or use the formula. We get x equals 2 and x equals 3. Step 3. Mark these points on a number line. They divide the line into regions. Step 4. Test each region. Pick any value in each region and check if it satisfies the original inequality. Test x equals 1, test x equals 2.5, test x equals 4. Step 5. Write your solution. Include the regions that work, x less than 2 or x greater than 3. That's it. Key points to remember. Inequalities give ranges, not exact values. Find critical values by solving equals 0. Test each region to find which satisfy the inequality. Greater than means above the x-axis. Less than means below. Practice makes perfect. Try it yourself.